All right, Friday. What did we do today? We looked at question number 9 and question number 8 off the set. Here's number 9, and I hope you can see all of these because the copy that we got was kind of bad. So I'm going to zoom in a little bit on this, and you're going to have to pause it and see if you can find all the segments. Everything in black is what was given. The names of the lines, like let me get my finger in here. P, W, V, U, T, Q, R, and S. Those are in there. And you can see some of the segments that are 5 and 3 and 6 and a few of the angles. What you need to find is what is in red, and those are identified. Again, go ahead and pause and write these down. And here is number 8. I went backwards again with this because I'm going to talk about 8 and then you're going to do number 9. Now, with number 8, we can do a few problems and know everything. So A, B, and C, and I need to know X, Y, and Z. And silly me, I didn't put those on there, but X is right here, Y is right here, and Z is over here. And you'll find that this is kind of easy. If I'm finding side lengths, I'm probably going to use proportions or similar figures. If I'm finding angles, anything that's related to an angle is a possibility of what can be used. And there's numerous possibilities and there's numerous answers. I'm just going to justify why I said something. So in this, I'm going to look at A first. A and C are the hardest, to be honest. How am I going to find A? Well, A is a part of this triangle right here. So I'm going to highlight that one. And I'm actually going to move it over here just so that I can kind of see A and 9. And I'm going to compare that. I could compare that to this triangle right here, but I don't know C. And I can't have two unknowns. So I need to compare it to a different triangle. So the different triangle that I'm going to compare it to, that I do know the values of, is this blue triangle. And you might be sitting there going, well, wait a second. I know this length here in the red triangle, but what about this length? Well, this length goes back to identifying what B is. So if I look at the bigger triangle here, being my blue triangle, I only know this segment to be 9. If I knew this, yeah, and the top of the blue triangle is 20. But what is this segment? Well, M and N are parallel, O and P are parallel. Hello, parallelogram. That means B is equivalent to 6. So over here, B is 6. I found it arbitrarily, just not really thinking, but why? And I found it because it's part of a parallelogram. Right? So here's my justification. This is 6 because of parallelogram. Same thing with this piece up here. This is 4 because it's a parallelogram. We know it's opposite. So now that I know this segment, 9 and 6, not 4, 4 is the one up there. 9 and 6 is 15. So now when I create my ratio, A over 9 is equal to my other ratio. I went A over 9. I went top to right. I go top to right over here. 20 equals 15. Take a second and solve that and see what you get. And by take a second, I mean pause. If you come back, you should have gotten A is equal to 12. Now, how do I get A is 12? A is 12 because I used similar figures. That was one of the things over here, similar figures. Similar figures, there's corresponding sides are proportional. All right, now I want to find C. Well, I'm going to use the same, because like I just said before, I couldn't use this triangle here because I didn't know A. But now that I know A, I'm going to use that red triangle, and I'm going to create another blue triangle with A being 12. So the top of this red triangle, sorry, go back over here. The top of this red triangle is 12 now. And I'm going to compare that to a bigger blue triangle, which is right here. And I know this segment here to here is 12. Remember, that's part of my red triangle right here. And this segment, which is 4, so 12 and 4 is 16, and I'm trying to find C. So now when I create my proportion comparing these two, I get 12 over 16, top to top. Yeah, I'm doing this a little bit differently. 12 over 16, right to right. 9 over C. Now, go ahead and take a moment and solve that and see what you come up with. And you should have gotten C is equal to 12. Okay, my diagram's not to scale. So now I've done those two problems, and I come over here and I'm going to say 12 because of similar figures again. And now I've got to find x, y, and z. Well, x, y, and z are angles, so I'm probably going to use these 4 things which are related to angles, not to sides. Do we need to find x first and then y and then z? No, you can do it in any order you want. What some people are knowing, gee, do I see corresponding angles anywhere? Corresponding angles. Well, gee, here and here. I see here and here are 80. Okay, well, what's going on? And actually, I take that back. This may not be 80 right here. I don't think it is. What I do know is I see corresponding angles with z and 40. So z is 40 degrees, and I'm just going to put corresponding angles. Now when I come back here, because m and n are parallel, x and y are corresponding, that means they're the same. If I know x, I know y. If I know y, I know x. And focus on the blue triangle right here. What do you notice about this blue triangle related to angles? I know 80, 40, and y. So 80 plus 40 plus y is equal to 180 degrees. 120, which I'm going to subtract from both sides. Y is equal to, and yeah, I'm shortening up the work a little bit. Don't do that. Y is equal to 60. So y is 60 degrees. And how did I find y at 60 degrees? I used the triangle sum theorem. Now, x is 60 degrees. Why? Because it's the same, yes. But why is x also 60 degrees? In this instance, I'm using corresponding angles. You always should justify y. All right? You should always justify it, give a reason, be able to. It's like I was telling a student, I could tell you the sky is green. No, it's not. Yeah, it is. I need to back up that it's green. So unless I come up with a reason, I can't say that. So your work that we did in class was number 9. Work on that. Find those segments. Toy around with it. Find as much as you can. Enjoy your weekend.